we look at the supply chain disruption during 2020, we certainly was able to learn some things from that situation that we could apply to an FAD outbreak or an some of our FAD preparation planning. We looked at diet manipulation as one potential option. We'll talk a little bit about the IRCC or the Iowa Resource Coordination Center. We also had the opportunity to look at and evaluate some depopulation methods as well as some disposal methods. We're talking about the slow growth diets. Obviously, our nutritionists and we as producers have been really singularly focused on maximizing lean accretion, growth rates, feed intakes, good feed conversions for finishing pigs. Never really thought about any reasons to slow pigs down, but certainly we did have that opportunity during the plant closures during the COVID-19 supply chain disruption in 2020. So there certainly are some occasional opportunities where we would need to slow pigs down, such as feed supply interruptions. Obviously, an FAD outbreak would cause that, or what we really ran into during the COVID-19 supply chain disruption is a total suspension of access to harvest facilities. We know it kind of hit its peak at the end of April of 2020, where the plant capacity utilization was down to 54% due to simultaneously temporary closures of many plants here in the Midwest. And really what that did is we were confident that after some changes were made in the plants to address any worker safety concerns, that we were going to be able to open those plants back up. But what it really showed us is that it kind of revealed that, we've kind of got a weak area there in the pork production supply chain to handle something similar to that. And that we didn't really have the ability to slow growth down, or we didn't know how to do it, never had the reasons to do it before, particularly those late finishing pigs just prior to slaughter. So doctors Nick Gabler, Laura Greiner, Jason Ross were able to mobilize an opportunity that they had with some research pigs to very quickly evaluate some different nutritional strategies to slow pig growth rates for those that were housed in late finishing pigs, and then simultaneously determine if there was any effects on carcass composition, pork quality, as well as looking at any potential animal welfare indicators as well. So in a period really of about a couple of months, they were actually able to complete and share the results from two different studies. So some of the different nutritional approaches that were evaluated looking to reduce growth rates were things such as bulking the diets up with a lot of fiber and lower energy content, with really kind of the hope that that would slow growth down and also reduce appetite. Another option certainly would be is to reduce the amount of crude protein and essential amino acids in order to restrict lean growth, either by lowering the lysine rate, and we know lysine is the first limiting amino acid, as well as looking at lowering branch chain amino acids such as isoleucine, which will also create an imbalance in that ratio and hopefully slow growth down. A third option also included adding dietary acidogenic salt such as calcium chloride in an attempt to suppress appetite and feed consumption. So two studies were done. The very first one was to evaluate and provide some data in this time of uncertainty about reducing finishing pig growth for 28 days, and all with ones that were very simple and practical to implement in a short time period. And at the same time, they were ones where we were making adjustments to the diets because we wanted to ensure that we had welfare-minded approaches. We didn't want to look at anything such as physically restricting feed or water in order to suppress feed intake. So that was the idea, to go ahead and evaluate that for a 28-day period. That was the first objective. And then the second objective after that 28 days was to put those pigs back on normal finishing diets, and then evaluate the compensatory growth that would take place in those pigs after that 28-day restriction, in order to evaluate how much weight will they gain back in the 14 days following that 28-day period at which we were attempting to slow growth and feed intake. So what we see here, very quickly, we're able to move it through the IPIC process to get approval for it. We looked at commercial crossbred genetics, 96 barrows and gilts weighing at about 160 pounds. They were blocked by body weight and sex, and then assigned to one of these 8 different dietary treatments. And there were about 12 pigs in each treatment. So those treatments included a control diet, so the pigs that would just remain on the normal diet in order to use these, have something to compare it to. We had 3 different fiber levels at 15, 20, and 25% neutral detergent fibers. Those are the 2nd, 3rd, and 4th treatments. 5th and 6th treatments, we're looking at reducing protein and synthetic amino acids. So the 5th treatment had no soybean meal. So essentially it was just a diet consisting of primarily corn and vitamin trace minerals. So no soybean meal or no synthetic amino acids were added to that diet. The 6th diet was looking at adding half the normal amount. So we had kind of a reduced soybean meal and synthetic amino acid diet. The 7th and 8th diets then were using the acidogenic dietary salts in order to suppress feed intake. And that was looking at 2 different levels, a 4% inclusion and a 2% inclusion of calcium chloride. So the next slide here, you see the results over the 28 days that those different diets were fed. The green, the control diet there you can see as the dashed line. And then you've got the 3 different neutral detergent fibers, and as well as the 2 diets that stood out in terms of really suppressing growth. And those were the 98% corn diet, so just corn and vitamin trace minerals there you can see in yellow or gold. That one was definitely significantly impacting piglet growth. And then the one that had the lowest growth, or actually almost completely halted any growth over that 28-day time period, was the higher inclusion of the calcium chloride, or the dietary acidogenic salt. So the next one is actually the compilation of all 42 days of the trial. So weeks 0 through 4 is the same as the graph before. We know at the beginning of the 5th week, then they were put back on the control diets, and we evaluated all groups to look at their growth rate. And what you can see is once the ones that had the largest decrease in body weight gain, the 98% corn diet and the 4% calcium chloride, you can see that they were able to recover a significant majority of the difference between those diets and the remaining diets in the control in the 14 days afterwards. So really, kind of in summary, that 98% corn diet, or some variation of it, was certainly a very common option to do, fairly easy to implement, and effective as well. Some producers were using that in combination with things such as tightening feeders or elevating barn temperatures in order to further suppress feed intake. Calcium chloride, particularly the 4% inclusion, appeared to be very popular, once again, fairly easy to implement, and used particularly when the growth needed to be stopped. So in some of those situations, producers were hanging on to pigs that were in that 320 to 330 pound range, waiting for the flow to resume going back into the packing plant. So they really didn't want those pigs to get any bigger, otherwise they start falling outside and incurring significant penalties for being outside of the sort loss window. Although we didn't show any graphic data in either one of those 2 studies, no negative vice behaviors were observed in any of the treatments. And then from a pork quality standpoint, we did see a slight increase in back fat from the 97% corn diets, and a slight reduction in pH and tenderness for the calcium chloride loins. Those are ones that were done in very objective meat quality measurements, but in all practicality, those differences are probably not big enough that they'd be noticed by a typical consumer of U.S. pork. What about feed additives, potentially to mitigate the risk of virus-contaminated feed if it was determined that that was a potential entryway of foreign animal disease causing virus, ASF in particular, could potentially come in contaminated feed or feed ingredients. And there's been a fair number of trials done led by Dr. Scott D, and the papers are listed there down below you can look at. But essentially what he was able to show in some modeling that he was able to do was that he had documented with lots of different viruses. Certainly the focus here is looking at Seneca virus, that's SVA that you see there up in the corner, which is a surrogate for foot and mouth disease virus. And then we were able to do some in the biosafety level 3 facilities at the Kansas State National Biosecurity Center. We're able to do some actual work with ASF as well. But essentially his modeling work showed that for a significant majority of the ingredients you see listed there, those viruses were able to maintain their viability in those ingredients over a couple of different transoceanic and transcontinental shipping time periods. And so essentially what Dr. D was able to do in those studies was take the ingredients, artificially spike them with either of those two viruses, and then put them in an environmental chamber where he could adjust the temperature and relative humidity. And then just took some weather historical data from a shipment modeled coming from both Asia and then from Europe into feed mills in Iowa, and took that weather data and plugged it into the environmental chamber so that they could essentially mimic those exact environmental temperature and relative humidity. Then at the end of that, he was able to take those ingredients and manufacture them into feed, and then feed them back to pigs and determine if the pigs were become infected with either the two ingredients or not. So everything you see there in the chart to the right in red were ones that were able to maintain their viability and infect pigs over those two transoceanic shipping models, and then still infect pigs at the end. He also did with some contemporary endemic viruses that we have here in the U.S. as well, and more detail are in both those papers. But essentially what it said was the virus survivability is variable and depends on the specific property of each virus. Certain feed ingredients or feed product actually present a better matrix for virus survival than others. And select ingredient matrices seem to enhance the survival of multiple viruses. Now, they've also done some work then in very similar situations where they went ahead and added different feed additives and then fed those back to pigs to see if they could still infect pigs or not. And what they found is there are feed additives out there that can mitigate those negative effects of virus-contaminated feed. In other words, actually halt or block or prevent transmission. So that work's been done with African swine fever, foot and mouth disease, and a lion's share of it's been done in a model that once again Dr. D put together looking at PRRS, PED, and Seneca virus. So Seneca virus once again being a surrogate for foot and mouth disease virus. So Mark Storley, one of our field specialists, was able to work with Dr. D in accumulating all that information and put together a very nice fact sheet that's available on the Iowa Pork Industry Center website. Here's just a couple of snips from that, looking at different products, the company, a little bit of description of what the product is, the different inclusion rates there, and most of the chart on the product on the chart here was looking at preventing infection of PED, Seneca virus, and PRRS. The one there outlined in red was actually one study that was done with African swine fever that was done at the National Biosecurity Center. And at that one, at the 0.33% inclusion of that product, was actually able to prevent infection with African swine fever. So once again, there's the nice fact sheet that was done. There's actually a document is maintained real time with the K-State feed group. And you can see the address to get there is ksufeed.org, which has kind of been a table that they keep updated. Summary of the information there. You can see once again the different products and the companies, the active ingredient, different inclusion rates, a relative guide to pricing, and then the number of studies that have been published that proves efficacy. And once again, you can see the one out. Most of them are once again done with PRRS, PED, Seneca virus. But the one there in red has been documented for African swine fever. And as new studies come out or as more information is learned, the information on that website gets kept updated. One thing important to know from a feed additive standpoint is, any of these claims of efficacy haven't been approved, reviewed and approved by the U.S. Food and Drug Administration. So you can't really go in and say, yep, I want to put this product in for mitigation of viral risk. They all have labels, so you just need to make sure you're working with your veterinarian nutritionist that you're using a product for the reasons that are labeled on the product. Once again, with the knowledge in the background that they're also effective at mitigating viruses that may have infected feed or feed ingredients. We'll talk a little bit about the Iowa Resource Coordination Center. So it was kind of a unique public-private partnership that happened during the COVID-19 supply chain disruption. And it was a joint effort really between the Iowa Pork Producers Association, the Iowa Department of Ag and Land Stewardship, and the Iowa Pork Industry Center. Since the COVID supply chain disruption really wasn't a foreign animal disease, there was really there wasn't a real organized effort or an organized structure to be able to provide some leadership here. So what we did, though, is we used the same incident management team structure that you would observe during a foreign animal disease outbreak to offer an opportunity for producers to call in if they needed resources or technical assistance, both for depopulation and disposal options. So kind of how that process all worked out, there were liaisons that producers would call into and get a hold of. And the liaison, some of the questions could be answered simply by looking up in a manual that was developed and kept updated, or the experts. If there was a scenario or question that wasn't in the manual, the liaison could go ahead and hook the producers up with Iowa Pork Industry Center experts to help evaluate that, provide some options, and in some cases, work with to do some small scale evaluations. And then the liaison would document that case, and case of learnings from that case, update the manual so that everybody learned together. So it really was a evolving, continuous improvement type of document that as the process moved along and we learned more about what people were doing and they were having successes with certain things or things that we're learning, we're able to update that manual for future use. There was some work that was done with depopulations. This is a chart that the veterinarians working with the producers would have to go through from a depopulation standpoint. Obviously, the preferred methods are all euthanasia methods that could be applied to those situations for depopulation. So those are always the most preferred. That's the first choice. If those could not be done or was deemed not to be successful in depopulating a large number of animals, then they could go ahead and move to those that are permitted in constrained circumstances. This is all outlined in the AVMA guidelines for depopulation of animals. So AVMA was working closely with veterinarians, had published this guideline, and there are allowances for some of these other ones that are only permitted in constrained circumstances, of which this supply chain disruption was deemed to be a constrained circumstance. So things such as sodium nitrate was evaluated, ventilation shutdown plus was another one as well. So veterinarians would have to work through this process to find the best one that fit each of the individual situations, and hopefully in most cases we're able to use preferred, but if not, then they had the ability in this guideline to justify using those that were in the permitted and constrained circumstances scenarios. So some of those things that we're able to utilize as a resource was looking at all the different considerations for mass depopulation methods. And unfortunately, in some of those situations where we're trying to use the preferred ones, there were other limitations, certainly from worker physical and mental danger, logistical issues in order to get it done, potential for animal welfare issues. So we developed this tool in conjunction with some veterinarians who had put some of this training together, and just utilizing and looking at the different options and what some of those issues might be when they had to look at options that moved from the preferred category into the ones that were allowed during constrained circumstances. And from a logistical standpoint too, certainly they were looking at, for some of these methods, evaluating the time period and the manpower that it would take to be able to successfully execute the depopulation. There were two of them that a group here at Iowa State was able to contract with the state of Iowa and USDA to look at taking a couple of preferred methods and scaling them up to be able to evaluate depopulation options. One of them was looking at CO2. Most cases, CO2 is used as a euthanasia method on sow farms for small pigs. So we wanted to evaluate if there was the opportunity to depopulate large animals and large number of animals utilizing different CO2 technologies. So what you see here was in conjunction with a producer that was looking at gearing up for the possibility of having to depopulate large numbers of finishing animals if the packing plants didn't open back up. Built this system here, you can see, which is a series of a couple of corrals where they could empty a half load of semi of pigs into each one of those and then apply CO2. And certainly CO2 fits a lot of the preferred categories to do it. Generally the biggest part is in the process of converting the liquid CO2 into the gas is a process that can take a long period of time and not simple and easy to do. We were able to work with some colleagues from the Pipestone group in Minnesota and evaluate these ambient air vaporizers. So as we're going from the liquid state to a gas state, it's very easy for that liquid to freeze up as it's being sublimated. So we were able to evaluate here in the situation where we would take the CO2 liquid tanks that we were able to acquire from companies such as Praxair. They're used in the human restaurant business as the fire suppression system. So they were available to be used. And then the question is how do we kind of rapidly convert that from the liquid state to the gas state? And where would we store that temporarily? So what you see here is these ambient air vaporizers, which are used more commonly in the welding industry. We were able to acquire one, and then in the process of sublimating the liquid CO2 into the gaseous state, we were using old LP tanks converted and hooked together to kind of feather those LP tanks, to feather the liquid gas and use the LP tanks as the temporary storage of from the liquid CO2 into the gaseous state. So what we're able to do is go ahead and fill those. To fill these 4 here, it took about 20 to 25 minutes. And then once we had the gas stored in the LP tanks, we would go ahead and unload the pigs into the corral that you see there. And then over a 5-minute period, we would go ahead and feather that gas from the tanks into the chambers. and then we would allow that gas to sit in the tarp covered chambers for about another 15 minutes, so a 20-minute total cycle period there. And then at the end of that, we would go ahead and roll the tarp back, allow the CO2 gas to escape, and then go in and evaluate the efficacy of the CO2 in this situation to effectively depopulate the pigs. And fortunately, we didn't have to do it a lot. We were able to do it with just a couple of small groups as the packing plants were able to be reopened. But in both tests that we did, we found that it was 100% effective at 20 minutes to successfully depopulate the pigs that were put into the corral. Here's another picture of a similar situation, but rather than using the permanent corrals, you can see they're using these large dump trucks as kind of the mobile chambers, one that could be moved and used around. You can't quite see off to the right, there's a trailer with the ambient air vaporizer in it. So the process of taking it from liquid to gas was very much the same, but then instead of feathering the gas into the corral, the gas was slowly put into these dump trucks, and then same sort of deal over a 5-minute period. After the gas was feathered into that trailer, they would go ahead and sit for another 15 minutes, and then the top was opened back up to allow the CO2 gas to escape, and then evaluated and make sure that all the pigs had been successfully depopulated. And then the dump truck would just go ahead and dump the carcasses out into the final resting place. Another option, working with the USDA and the state of Iowa, was looking at a mobile device utilizing some equipment from the packing plant. So what you'll see here was, again, just a small demonstration of this thing that was fabricated, this device that was fabricated. And essentially what you see here is took V restrainers from an old packing plant and mounted it onto a mobile trailer that was built, and then that was put into kind of a two-step depopulation device, whereas the pigs would be loaded in to the mobile V restrainer. The first person there would go ahead and electrically stun those with a commercial stunner, and then the person at the end was using a pneumatic captive bolt gun to successfully depopulate the animals as they came about, and then the carcasses would slide off there and then be removed by personnel in skid loaders. So once again, that was put together. Plans were developed, SOPs for both the CO2 and this V restrainer are located on the Iowa Pork Industry Center website. That's once again at www.ipic.iastate.edu. So that was some different things that were evaluated from a depopulation method. There were various methods evaluated looking at disposal as well. Because this was not a disease emergency situation, there was the option to go ahead and remove these carcasses into rendering for the COVID-19 supply chain disruption. But there were some people that wanted to evaluate some different disposal methods so that we could increase our knowledge in case of a foreign animal disease event. So looked at things such as deep burial, shallow burial, grinded composting, and then in some cases composting utilizing cattle manure as the carbon source. So deep burial, certainly there's a website for the state of Iowa for acceptable places to do that. The concern with the deep burial is the potential, particularly in an African swine fever outbreak, because that virus is so resilient and resistant in the environment that it may eventually contaminate a water source, and that virus doesn't take very much of that virus in the water to infect pigs. That work had been done here in the U.S. at the K-State National Biosecurity Center. So shallow burial certainly has the advantage of keeping it shallow enough that it wouldn't get into the water supply. Grinded composting is another system that was evaluated as well. So the shallow burial, there's been a couple of NADPREP USDA grants that were put out there looking at evaluating this work that's been done both at South Dakota State and Oklahoma State University. So you can see here just shallow trenches that were built, and then a carbon source that was put on the bottom of it and then covered back up. So that work's been done. It does take a little bit of time, but certainly was effective in properly disposing of and degrading those carcasses over time. It was a little bit cheaper option than some of the other ones, particularly if you have the land available. You certainly, to do it, you still need access to a carbon source and some earth moving equipment. So we did some preliminary modeling in 2020 to understand what the cost of that would be, and it was modeled somewhere to be about $5 to $7 per carcass, with the labor and equipment rental and carbon costs at that time. Grind and composting, that one was actually picked up from some producers that had done that in the Southeast, in situations where they needed to do some mass burial. And essentially with this one, it's really composting, but it's really putting a commercial grade tree grinder in front of it to help break the carcasses down, increase the surface area, and allow the composting process to occur much quicker. So they were done using the commercial tree grinders, some of them anywhere from 550 to 1100 horsepower. They put together, and to do it successfully, you kind of have equal parts of compost material and carcass going through that grind and composter, whether it was straw, corn stalks, wood chips, whatever people could get their hands on. It'd been done and estimated to be able to do about 10 carcasses per minute. And then those compost piles were monitored, and the final composting material achieves about 165 degrees within a couple of days, which has been seen to inactivate viruses such as African swine fever in that time period very quickly. And everything was completely composted within about 30 days. So a much shorter time period than just making a traditional compost pile with whole carcasses. Now that cost was modeled to be a little bit more expensive, kind of depending on the cost of the carbon source and rental of the equipment needed to do that. That was a little bit more, about $20 to $30 per carcass back in 2020. If you were just doing a traditional compost pile, certainly there's a lot of resources here at Iowa State University working with the ag extension agents. Can certainly put you in touch with any of them if that's something you're interested in. If we're just doing a traditional compost pile, we want to make sure it's wide enough, 15 to 20 feet, and that we've got 12 to 24 inches of a base layer of a bulking agent of that carbon source. You can place mortalities in a single layer and at least 6 inches from the edge, and then covered once again with another 12 to 18 inches of that bulking agent in a mound shape. We want to monitor the temperature, make sure we've got over 110 degrees for 5 days. It should really be maintained at that 130 to 160 degree temperature range. And then for those, you may have to go ahead and turn the pile if necessary, if that temperature drops to about 100 degrees. And then obviously with that one, you want to inspect regularly, maintain cover, make sure we don't have any carrion animals that would be there to scavenge the carcasses and potentially drag them off and create another biosecurity issue as well.